So, dear students, now I'm going to discuss about complement fixation test. This particular uh, topic is there in your module 2 of course immunology. The complement fixation test was first used for the study of, mostly for the serological study of syphilis, sexually transmitted disease caused by Treponema pallidum, and it was introduced in 1909 by Wasserman. Here, the complement is a protein, it's a serum protein, a globular protein that is present in normal serum, and whole complement system is composed of 9 components, and these are marked as C1 to C9. So these proteins are very much heat labile, means they are heat sensitive, and with a little exposure to heat at 56 degrees centigrade for 20 to 30 minutes, so all the complement subunit proteins will be destroyed. So complement proteins bind to antigen-antibody complex. When the antigen is an RBC, it causes lysis of the red blood cells. Now I'm coming to the principle of this particular test. So complement takes part in many of the immunological reactions. So we have already studied 2 immunological reactions, precipitation reaction and agglutination reaction. So likewise, complement are the globular protein or serum protein that actually take part in many of the immunological reactions. So particularly it gets absorbed during the combination of antigen and antibody. It's when antigen and antibody combine with each other and forming a complex. So this property of antigen-antibody complex to fix the complement is used for complement fixation test for the identification of specific antibody. And the hemolytic systems, if RBC were used containing CIF erythrocyte or CIF RBC and its corresponding antibody that is termed as amboceptor is used as an indicator which shows the utilization or availability of the complement. If the complement is fixed, then there will be no lysis of CIF erythrocyte, and this particular test will be called as positive test. So hemolysis doesn't mean that the complement fixation test is positive. It's a reverse thing. So if complements are fixed, then there will be no lysis of the erythrocyte isolated from CIF, and then we can say this test is positive test. And if hemolysis occurs, means complement is absent there, or we can say that the test is negative. So complement system or complement fixation test have 5 different components, and these components are classed as test system and as indicator system or hemolytic system. So in the test system, you can see there are 3 different components are there. The first one is the antigen, and this particular antigen must be soluble or particulate. The second component is the antibody. It is nothing but the human serum raised towards a specific antigen. The third one is a complement, and this particular complement you can isolate, or you can get from by pooling the serum obtained from 4 to 5 guinea pig. And as I said that complement proteins, protein subunits, they are very much heat sensitive or heat labile. So we have to prepare this complement from the guinea pig serum, and this complement should be fresh, and this should be preserved at minus 20 degrees centigrade to retain its function. And when we are going to preserve this in minus 20 degrees centigrade, we must aliquot it, and then in small fractions or in aliquot we will keep it. So freeze thaw repeated times of freezing and thawing will lose the activity of the complement. The complement activity should be initially standardized and before starting your experiment or the test. Next one is an indicator system. This is the hemolytic system. So for that purpose, we need two different things. One is your erythrocyte, that is RBC. When this RBC we will collect from tiger sheep, mostly from sheep, and the second one is the amboceptor, that is hemolysin. And this hemolysin is rabbit antibody to sheep red blood cells prepared in inoculating sheep erythrocytes into rabbit under standard immunization protocol. So first we have to prepare this amboceptor, that is the hemolysin, and then we can add erythrocyte to check. So these are the 5 different components we must need for the complement fixation test or complement fixation study. Now this particular test, there are 2 types of tests, maybe positive, maybe negative, and all the tests have 2 steps process. The first step is the antigen antibody complexation along with the complement. So antigen, antibody, and complement, that is getting from the serum, will be mixed at 37 degrees centigrade and incubate for 1 hour at that particular temperature to fix the complement and with antigen and antibody. After fixing is over, then the fixed complement complex will add with the hemolytic system, means your RBC as well as amboceptor. And again, we have to incubate this mixture at 37 degrees centigrade for 1 more hour. And if we are not noticed any hemolysis, then we can say that okay, this test is positive. So no hemolysis occur means the test is positive. The second test, that is negative test, the same kind of test. So first step, we must add antigen, then antibody is absent here. The difference is between the positive and negative test is that antibody is absent here. So the complement will interact with the antigen, and it is not fixed by the antigen, it is fixed only by the antibody. So as antibody is missing here, so and the complement will not be fixed, and this complement will interact with the second antibody that is present in your hemolytic system, with the amboceptor. So here the hemolysin will interact with the free complement that has not fixed with the antigen and antibody, because antibody is absent here. So hemolytic system will function with the with the action of free component, free complement, and hemolysis occurs. So if there is hemolysis after incubation of 1 hour at 37 degrees centigrade, then we can say that this test is negative. So this is how the complement test is performed. This is a schematic diagram. So here in the first tube, the blue, you can see that the antigen, antibody, and the complement proteins are added here. Incubate at 4 degrees centigrade for 15 to 18 hours. And then we are adding the hemolytic system, means it is sick RBC, along with the antibody raised in sick blood. So we are incubating both at 37 degrees centigrade for 15 minutes, and then to send the sensitization of to sensitize the RBCs, and then mix it together, incubate it at 37 degrees centigrade for 1 hour, and then examine whether hemolysis is there or not. If hemolysis is there, then we can say that complement is unfixed, means antibody is absent there. And if it is no hemolysis, then we can say complement is fixed and antibody is present there. So due to antigen antibody complexation reaction along with the complement, so complement is fixed here. But in this particular test, when hemolysis occurs, means we can say that complement is free here, that is interacting with the hemolysis lytic system, and then it is actually doing hemolysis. So free due to presence of the free complement protein. Now, how to interpret your data? Your data has been interpreted like that. The no hemolysis is considered as a positive test, and hemolysis will consider as a negative test. And this particular test people are performing this particular test using microtiter plate, means 9612 plate. These are the plate, 96 small wells are there, 200 to 250 microliter of your solution can be kept there, and you can pour there. So this microtiter plate showing that hemolysis occurs in well A1, A3, better to say A3. Here in A2, A1 is no hemolysis is there, but A2 slight hemolysis, but it is prominent in A3 and A4 and B4. A3 should be A4, so A3, A4, and B4, and no hemolysis in these wells. In these four wells, no hemolysis is there. So as there is no hemolysis, so we can say that this is positive and these are negative. That's all.